Hello everyone, a very warm welcome to day 4 of AWS Gujarat Student Builder Week 2026. It's wonderful to have all of you joining us once again over the past 3 days. We explored cloud fundamentals, compute services, serverless computing, and networking. Today, we are taking the next step by understanding how to design applications that are scalable and ready for productions on AWS. I am Hardik Bandya, one of the organizing team members, and on behalf of all the AWS student builder groups and AWS user groups across Gujarat, I did like to thank each one of you for being part of this amazing learning journey. Before we begin, just a quick reminder. Please stay till the end of the session to mark your attendance. Feel free to ask your questions in the chat. We will have a Q&A at the session's end. If you are enjoying this series, don't forget to share your learning on AWS Builder Center and inspire more builders in the community. Now, it is my absolute pleasure to introduce today's speaker. We are honored to have Praful Bagai, DevRel Head at AWS, with us today. Praful Sir has been actively empowering developers and communities by helping them learn modern cloud technologies and build impactful solutions. Today, he will be sharing his expertise on scalable cloud architecture on AWS, covering how real world applications are designed to scale, remain highly available, and deliver reliable experience to users. I'm sure today's session will be packed with practical insights and valuable takeaway. Please join me in giving a warm virtual welcome to Praful Sir. Over to you, sir.
Thank you, everyone. And thank you, Hardik, as well. Folks, it's a great pleasure to be here in front of you and discussing about the different challenges. And I have been following this specific series from past 3 days, right from the launch for the until the next two sessions, and it was very quite engaging sessions as well. And Hardik and the team actually reached out to me to give a session and for the cloud architecture, and it's always be my pleasure to talk about and teach about the different set of technologies. And because I believe by sharing the knowledge, I also gain something, and I also empower the builders as well. With that being said, folks, good evening, everyone. Today, I'm going to actually discuss about the cloud architecture, and I love when it's an interactive session. So let's do a quick warm up. Drop a message in a chat with your name, college, and age, and what did you wanted to become during your childhood. I can actually start with myself, and I'm Praful. I head the developer relations for India and South Asia. I belong from Guru Tegh Bahadur Institute of Technology, which is in Delhi, and right now I'm 35 years young. I wanted to be a professional cricketer. I was a left-hand batsman and a right-hand bowler. I would love to hear and see what all of you wanted to be during your childhood days. Lovely to know you, Anjali Dubey. Deep from Darshan University. That's nice to know. Dhruv from Darshan University again. Darshan, Dhruv, what did you wanted to become during your childhood? Or Pritham? Pratham, sorry, my bad. Welcome, Yukta. Everyone wanted to become a cricketer. What, definitely. All right, folks, I'll move on. Folks, before we actually begin talking about the scalable architecture, I want to actually ask you another specific question. How many of you have an app idea? It can be a startup, it can be a hackathon project as well, or it may be your final year project too. Today, it isn't about AWS. It actually about what happens when your idea succeeds, because success changes everything. I would like to actually know what you folks are actually building right now. That's Dhruv wanted to be an astronaut. That's amazing. Folks, what are you building right now? Any specific idea that you folks are actually working upon? maybe a small hackathon project or a college internship project as well. Game like a GTA, wow. And in fact, I that's amazing, DVL gamers specifically because if I'm not mistaken, the recent version of GTA was the most expensive one. The most, if I'm not mistaken. Though I used to play GTA, I'm now more of a FIFA fan, Messi fan specifically. So yeah, if anyone is actually a FIFA player and loves to play the recent version of FIFA, I'm all game for it. You can actually send me a request on Praful Bagai. I'll be more than happy to actually go through and play some games with you folks. Wow, designing a fashion designing app using Gen AI. That's amazing. Perfect, folks. My favorite FIFA team is Chelsea. I'm a Chelsea fan. All right, folks. Let's move on. So imagine that you are actually sitting in your hostel room and working on some of your core project, be it your hackathon or be it your startup or be it any specific project. For the context of this meet, we'll actually discuss how we can actually create a campus connect program or an application. It's an application where students actually connect and discover the events, join hackathons, and do some mentorship itself. Consider that you're actually building this app over a weekend with no investors, no DevOps team, no cloud architect. It is just you. How you would actually take the road to 1 million users. There are different stages for it. Stage one actually includes the servers. Stage two have a different set of users, and then so on and so forth itself. So over the next 1 hour, we are going to travel this road together. We are going to build, we are not going to learn about different AWS services, but we are going to learn why they exist. Because every AWS service was born from a real engineering problem. And our job as architects isn't to memorize services. I cannot, AWS is a huge ecosystem, it's a huge universe in itself. I cannot work on all of those services. I cannot memorize all of those services. I cannot build expertise on all of those services. It's to recognize problem and know how to use them and when to use them as well. So over the next 1 hour, we are going to actually travel through this road and identify which all services is actually suitable for a particular set of use cases. All right, so it's your day one, it's your stage one. Every project begins here. Nobody begins with Kubernetes, nobody begins with 20 microservices, nobody begins with auto scaling. They begin with an idea. They just have a laptop and a vision and an aspiration to succeed. Let's actually quickly move to architecture, how my initial architecture would look like. So if I want to actually create a campus connect kind of a system, what I'll be actually be having is a client. This is my client. This is my web server or a Django application. It can be any specific application. So during my times, I used to be very proficient within Python stack and I used to use Django framework. And hence I'll be using Django in the upcoming terminologies as well. So consider this as a Django web server, which is an EC2, a single EC2 instance. So in this, I wanted to have one specific database. I'll be having some of my image folders as well, which I'll actually be uploading it. And then maybe I'll be using some internal Redis cache as well. This becomes my internal locally hosted Redis cache. This becomes my image folder, and this is my MySQL database. All of this, please mind you, this is all locally hosted. MySQL database. I just then actually deployed it on an EC2 itself, and poof, my application is live on a specific URL. With that being said, let's move on to the next part. So now imagine you wake up you woke up a specific morning and your notifications keeps increasing. Your downloads keep increasing. Students are actually loving your app. This is a dream, right? Is it? Definitely it is. For a business person, for an entrepreneur, for a visionary person, it definitely is. However, everyone celebrates growth. Engineers worry about it. Because every new user asks your architecture a question. Can you still handle me? The scale actually asks that specific question. The success actually asks that specific question. Can you handle my request in the most optimal time? Is your architecture scalable? Because users does not care about what goes behind the scene. They just care about the first hand experience that your application or that your product is actually providing the users. With that being said, folks, let's do a quick poll. I started from day one, from me being the only user, and now I have, after a week of it going live, I now have around 500 to 1,000 users on my application. What, according to you, will break first? Please share your answers in the chat. What do you think? Is it the CPU? Is it the memory? Is it the database? Is it the storage or the network? Haaland is not gonna break, buddy. He is gonna break others people's legs. And yes, I used to follow Man City as well. That's a nice one. Network. Anyone else? Folks, let's be more interactive. Network, another thing. So we have two votes for the network, four votes from the network. What if I tell you, folks, there is no universally correct answer? It can be CPU, it can be a memory, it can be your database as well, it can be storage, or it can be anything. It's all about observing. You need to think like a doctor. A doctor does not prescribe medicines first, he diagnoses. Architecture is exactly the same. I just cannot predict that this must be breaking. I need to see some logs. I need to see some monitoring or observability tool for me to identify and say for sure that this is the part which is breaking. And it can be anything. As I just mentioned, there is no universally correct answer. It can be anything. I need to first diagnose and then come up with a specific solution. This is probably the most important slide in today's talk. If you remember nothing else, just remember this. There is no such thing as a universally scalable architecture. Every architecture fails. The great ones actually recover. Stop designing for the imaginary users, my friends. Start designing for your today's users and then evolve. As you can rightly see, I started with with a specific set of users. I started with a specific set of my architecture, which was this. Now this architecture is not scalable anymore. With the amount of users or with the number of users that I actually have on my application, this architecture is not scalable anymore. So I need to actually do something with respect to this specific architecture so that it can handle more load. It can handle more requests. All right, as I just mentioned, so you need to actually think like a doctor. Doctor actually diagnoses. It does not prescribe you the medicine. Architecture is exactly the same. Most people actually skip straight to the AWS services, as some of you have actually mentioned in the chat as well. But the experienced people do not. They observe first, they collect evidences, they understand the bottleneck. Only then do they change the architecture. This mindset will save you countless of hours in your career. I'll say that again. It's all about looking and diagnosing the root cause, observing the evidence, and then making the change accordingly. Quick question again. In this specific architecture, where we were actually designing it from our day one architecture, what changed? The code did not change. The database did not change. Neither did my EC2 instance. Only one thing changed, which is the demand. My scale shifted from 1 to 5,000 users. My scale actually grew out of my own expectations as itself. Architecture isn't about softwares. I can use any specific service. I can use any specific tool. I can use any specific open source tool or managed tool as well. Architecture is all about demand and adhering to that specific demand as well. You remember I said that there is no right or wrong answer. Notice what I'm not doing. I'm not adding more servers yet. I am not actually scaling out or scaling in as well. I'm not actually scaling vertically as well. I'm not adding more databases as well, because adding resources before understanding the problem is expensive. I'm observing the things first. I'm observing the matrices. Is it my CPU who's actually going above? Is it my disk utilization? I'm actually analyzing my logs and triggering all of those alarms itself. Now we come up to a vertical scaling and the horizontal scaling. As you knew that my architecture or my architecture was not actually scalable to 5,000 users, the first step that I can actually do is increase the type of my machine. This is called vertical scaling. It's often the faster type, fastest fix, my bad. No code changes, minimal operational effort. It's all about that. I have a CPU size of, let's say, 1 GB RAM. I'm not actually increasing it to 2 GB or to 3 GB or to 4 GB, or basis on how much money I have in my wallet. It can be a T3 micro, as it's been rightly mentioned as well. It can be a T3 large, or it can be an MXI 2X large as well. The question is, can you keep buying bigger machines forever? Eventually, you will definitely hit a ceiling. There is no specific machine that can actually grow infinite. There will definitely be a point that your machine cannot vertically scale beyond a specific point. And then you have a horizontal scaling. Instead of building one giant, or instead of having one giant machine, how about if I have multiple machines of the same type? This is usually how internet scales. It's how when the systems grow. However, now with horizontal scaling, I land up upon a different problem altogether. Let's go back to this architecture once again and see how horizontal scaling works. I am actually, so these are my two exactly same machines. These are my exactly same machines. So I just actually added another instance of EC2 of the same type that my previous instance was, and I then just routed these requests in a round robin fashion. I'll actually add an application load balancer ELB load balancer. I'll add a load balancer, and then my request will be routed via the load balancer to each specific instance altogether. All right, so this is my load balancer. And basis on the round robin fashion, whenever, let's say, a client is actually hitting my server or requesting my server for the first time, basis on the round robin fashion, there are different types of load balancer strategies as well. But I usually follow the round robin fashion. So based on the round robin fashion, if your request one is actually traversing to this one, the next request will be going to this specific instance itself. This is how I am actually horizontally scaling my architecture. Instead of all of the requests going to the same instance every single time, I am actually dividing all of those requests into multiple instances. I literally reduced the amount of request on this specific instance by a half. If I add another instance, I'm literally reducing the request by one third itself. So for the sake of simplicity, I'll just have two instances during the entire conversation that I have. However, now think about, or now let's actually talk about the challenges that this specific architecture might have. This is a V2 architecture that we just designed. Let's now think upon the different challenges that this specific architecture may have. Consider my user is actually logging in. That's a login request, wherein the first request actually goes into this specific server, and the session is stored locally. The next request, let's say I want to access my home page. The next request will be routed to this specific instance. This instance would actually say that, hey, this request is unauthenticated or is not authorized to actually access it. How do I actually solve for this problem now? Let's go back to our slides. As I just mentioned, will this even work? Having or distributing our specific request into two different instances does actually have multiple problems as well. The solution is to have a stateless machines, to have a stateless mindset. You have an EC2 instance, sorry, for applications to scale horizontally, each server should behave like a stateless instance. What do I mean by a stateless instance? That it just does the compute. It does not store any session. It does not store any specific data. It does not have any specific knowledge about this specific user. The request comes and just goes. Stateless application makes scaling much easier because any server can handle any request. If I actually add 10 more servers like these, it will be able to handle those requests. Compute should be replaceable. Your storage should be durable. And hence, S3 or your databases or your Elastic Cache, when you separate them, your architecture becomes much more resilient. I'll move on to the architecture 3 now. So this was our version 2. How can I actually make this specific architecture to be much more reliant, to be stateless, and much more durable as well? What I'll rather do right now is I'll add a common RDS, which is my database. I'll probably have an elastic cache as well. I'll have a cache as well, and probably I can also have. and S3 too. So note that now that these are, let me just actually back. So these are all my different AWS services that I want to interact with. Now, since I actually made all of these common, this is my S3, this is my Elastic Cache, this is my RDS, which is my database. Now, since I actually have all of this in a common format, what I'd rather do is rather than actually keeping all of that logic into my EC2 instances locally, I just actually decouple it. Please note that decoupling is of the utmost importance because if I keep on having this into my local system, I'll again come back to the same problem statement again. So I'll remove this. I'll remove this as well. I'll come on to this image folder later in our discussion. Now, what I'm actually doing is I'm actually now letting making them decouple. I just made them decouple, sorry. I just made it decouple. And now, if any request that comes into either of the servers, either of the EC2 instances, the data is fetched from a common storage, which is either Elastic Cache, RDS, or S3 itself. That way, I just made all of this specific problem statement or that specific problem statement which was there uh, has been resolved now. Please note that I didn't replace everything. I just evolved myself. Each component exists because we encountered a problem in my previous architecture. And that's how every architecture grows as well. It grows incrementally, it grows intentionally as well, and especially in response to the changing requirements. The requirement here is specifically that my application has scaled from user 1 to 5,000 users. Moving on, did you notice something interesting over here? As my application is growing, the problems change. At one user, I was worried about writing some code. At probably 100 users, I'm much more worried about can I actually survive this Monday morning itself. Scaling is all about technology. Or, sorry, my bad. Scaling is less about technology, it's all about changing priorities. Let me repeat this. Scaling is less about technology, it's all about changing the priority. And I'll tell you a very real life example as well. I was at the AWS Summit as well, and I happened to actually interact with multiple builders who was actually building, one of those builders was actually building a customer support over a phone call itself. And he happened to actually interact with me to just ideate upon a specific problem statement that he was actually encountering over here. He mentioned he wanted to use agentic AI. I can actually answer what agentic AI is, but that is actually out of scope for this discussion. I wanted to understand his problem statement more so that I can guide him the right way itself. So he mentioned that it's the same customer support that we usually have over a phone call where I press 1, 2, 3, 4, 5, 6, and it then keeps getting routed towards the different categories itself. He wanted to do it over a voice call itself. When I say a voice call, so there would be a specific bot who would be speaking out, and it would be a live audio interaction itself, minus the phone numbers, keypad numbers itself. I wanted to understand why does he wants to build that specific thing. Is the normal keypad thing not working at all, or is there a specific ask from the business for that? He didn't have a clear-cut answer to that. So I specifically pressed him to follow a normal workflow model like a step functions or any specific workflow manager itself, and hence not to go after a buzzing technology which is AI and agentic AI or Gen AI itself. So scaling is less about technology; it's all about your business requirements and your changing priorities as well. All right, moving on. We just saw how the version 3 of the architecture looks like. One of the biggest misconception in the software engineering is that architecture is just a one-time activity. I'd like to actually share a bad news. It is not. Every product launch, every marketing campaign, every feature, every acquisition changes your architecture. The best architectures or yes, the best architectures are not permanent at all. They are adaptable. So if architecture is never finished, where do we look next? Like if now I'm actually also again encountering a problem in my architecture v3, which we just actually horizontally scaled and made it decoupled. Now I'm actually having a specific problem statement again with that specific architecture. Where should I actually go next? Let's just actually follow the request. So over here, I have intentionally made that my RDS is a bottleneck. But how did I actually landed upon that? I'll tell you upon that how that specific point as well. So I followed a specific one request, which was going or only milliseconds are actually spent executing my code. So I actually established all of my observability tools. I established my CloudWatch logs. I established all of my APM tooling as well. So most of the time was spent waiting for the database, waiting for the storage, waiting for the network. Optimizing software often means reducing waiting, not writing faster code. Sorry, not writing faster code itself. Architecture teaches us something very powerful. Adding resources to the wrong places does not improve the performance. It increases the cost. So I can actually add tons of EC2 instance and keep that keep it scaling horizontally itself. But if the problem lies somewhere else, it increases the cost. The first responsibility, as I keep on saying, is to find the bottleneck, is to diagnose the system rightly, not buying more infrastructure. Imagine you are checking the event schedule, like for this specific events, Hardik must have actually posted it somewhere, and this event is not going to change every single day. Thousands of people are actually asking the same question. Why should a database actually answer that? Why should my code actually even process that specific scenario itself? Because every specific processing, every specific IO operation increases my latency and it increases the load on my backend as well. Introducing the Amazon CloudFront and the Elastic Cache as well. CloudFront isn't magic. Elastic Cache isn't magic as well. It just simply moves your data and keeps it either into the memory in case of your Elastic Cache, or it simply moves the data closer to your users. Architecture often wins by reducing the distance. And I'll show you how I can actually incorporate both CloudFront and Elastic Cache into my architecture v4. Moving on for the another problem statement. You remember I was actually talking about this images folder. Consider I'm actually uploading a specific image on one specific instance based on the round robin fashion, the horizontally scaled. So the image has been uploaded on this server. Now, if the second request is actually going on to this specific server, This server does not have that previously uploaded image locally. How do I actually solve for that? How do I solve for that? So, and also while I'm actually uploading that image onto the server as well, it is blocking my network because any input IO, sorry, any IO operation does involves your network latency. And do consider if I'm actually uploading a 50 MB image with the kind of phones that we have, I am able to easily assume that it may be around 5 to 10 MB or even definitely more than that as well. Any high resolution image will be definitely more than that as well. So if I'm uploading that specific image onto a specific server, it's a synchronous task. Do I actually need to want that? Do I does my architecture really should keep the complete network, the complete IO blocked? I don't think so, because we can definitely optimize on that previous architecture. So, as I just asked you the question, should my user wait for the backend execution or consider a scenario like this? For a scenario like WhatsApp, I'm uploading the image and I'm again typing out all the messages as well. So until and unless my previous image has not been uploaded, should I actually not keep on with my previous messages? I should definitely. So how should I actually tackle that part? That's where the concept of synchronous and asynchronous comes in. This is one of the biggest shift in architectural thinking. Not everything needs to happen before responding to the user. Your queues decouple your work. It improves your responsiveness and it increases resilience. You can definitely use Amazon SQS for that. Or there's even a better approach, which I'm going to talk about how you can actually upload the images in a totally asynchronous way. So architectures are like busy airports. Airports don't ask every passenger to wait until your suitcase has been loaded before boarding begins. Everything happens in parallel. Great architectures actually works or embraces the parallelism where it makes sense. For situations like image upload, for situations like sending of the email, for situations like very heavy backend tasks, I can definitely do it over in a backend fashion itself. Moving on, with respect to the different concept, high availability. What does high availability means, folks? I am actually designing my system so that a single failure does not becomes a customer outage. You must have actually seen multiple news out into the public as well that one of the data centers actually went down and there was a huge havoc. How can I actually fix that? I can definitely have my application productionized or deployed at multiple different data centers, at multiple different regions as well. And that also avoids deep networking details. The takeaway is redundancy across the independent infrastructure. Another point that we would should definitely consider while designing a great architecture. Consider we are actually or taking the previous example itself about this campus connect itself, all of our students or during my childhood days, I was a night owler. I used to stay awake somewhere until 6 or 7 a.m. and then I used to sleep. So, and if this application is specifically made and designed for students, I can see a pattern that when does my traffic actually lowers down and when does it actually scales up as well. So I don't need to have hundreds of machines horizontally scaled at every single point of time. It is very expensive. It is very costly for me. So why should I be paying for hundreds of servers when or when my demand is really very low? Elasticity means matching capacity to demand. We can definitely introduce auto scaling groups where basis on the threshold that you set, user can either upscale or you can downscale as well. It's just a matter of some configurations, and AWS will automatically upscale. So let's say, for example, your CPU threshold that you have set is around 80%. And the moment that threshold actually touches that, it would be automatically spinning up another specific instance for the smooth processing itself. Or if your storage is actually, or if your request is actually increasing way too much, it can automatically scale without you intervening manually itself. The best part is the moment the scale goes down, which means by below the threshold that you have set, maybe 80% or whatever percent is that, it will automatically decommission those services as well, or those instances as well, thereby giving you a most cost-effective solution as well. And I did just mention, auto scaling groups is something that you can actually provision and with zero manual intervention itself. CloudWatch, Amazon CloudWatch, which I just discussed previously as well. I cannot diagnose any architecture of mine. I cannot diagnose any architecture of mine without the right tool sets. It's like I'm a carpenter. I cannot actually fix a door without having a hammer or without having my saw as well. I need to have my tools in order to identify, debug, and diagnose and find the actual root cause slash bottleneck. Amazon CloudWatch does give you a great infrastructure and a great experience about going through the logs, understanding your CPU threshold limits, your average latency time as well, your error rates if that has been set to. Metrics don't fix your problem though. They just reveal before your customer notices. You need to set up some alarm slash triggers that can automatically notify you for any specific mishap that may occur or that may have already occurred. With that being said, let's move on to the architecture V3, which, so this was my V3 architecture. Now, how can I actually devise all of this? How can I actually make this much more compatible to my existing load and to my existing demands as well? I renamed this as V4. As I mentioned, I'll talk about this images folder as well. There is a concept called pre-signed URL in Amazon S3. What the client would actually be doing is client would, so let me just actually create another microservice. This is a image microservice. This is an image microservice, dedicated microservice. And now my client will be requesting a pre-signed URL. It's called requesting a pre-signed URL. So this would actually interact with S3. It would interact with S3. S3 would return a specific URL, which this microservice will return it back to the client. Now the client, so this would actually returns this should actually come over here. It should go via the load balancer again. So this will return a pre-signed URL. Pre-signed URL. Now the client can directly upload it onto this URL itself. It does not need to interact with my server at all, thereby freeing up the network bandwidth, thereby freeing up my CPU usage as well, thereby freeing up any IO operations too. Now, this client will directly upload it onto my S3 itself. To make it a bit simpler, it would now directly upload my image upload onto my S3 itself. S3 is highly durable, it's highly resilient, and its uptime is, if I'm not mistaken, around 6 or 7 nines. So I can directly use this pre-signed S3 URL to upload it onto the S3 itself. And that S3 pre-signed URL is actually saved into my RDS database itself. Now, to improvise this a bit more, as I mentioned, there can be some of the synchronous tasks as well. There can be some asynchronous tasks as well. An asynchronous task, as I just mentioned, is an image upload, which I actually solved it using S3. But there can be other asynchronous or heavy IO operation tasks as well. For example, and sending of an email. I don't need to keep my server or keep my instance or keep my network blocked until and unless an email is sent. I can definitely do that in parallel. So what I'll rather do is I'll have an SQS. I'll have an SQS. These application servers will be sending a task, sending an email task to an SQS. This SQS, there will be multiple workers. It can be a Lambda worker as well. Sorry, not this one. It can be a Lambda worker, or it can be your normal Python application as well, or a normal EC2 instance as well. This Lambda worker is actually fetching the task from your SQS, or it also triggers. My bad, sorry, it should not be fetching it. So SQS actually triggers it. This should be opposite reverse. Yes. So it triggers a email Lambda function, Lambda worker, and then it actually sends out a specific email itself. With that being said, folks, as I just mentioned, now this specific architecture, I have scaled it to my specific requirements itself. Initially, I started with V1 of architecture with everything monolith, everything inside my local architecture itself, or in my local instance itself. Now, I just actually scaled it horizontally, added some asynchronous queues as well, decoupled my architecture to the one part is still remaining, which I'll talk upon in my upcoming slides as well, which is the most important part. Moving on, folks. So far, we have learned how to scale an application. Next, we'll learn how to keep it alive when things actually fail without our expectations. Because, as I just mentioned, everything fails. There is no architecture which is a perfect architecture. There is no perfect scalable architecture. Please expect that your architecture will fail. Your cloud or your AWS or any specific cloud provider does not eliminate the complexity. It just gives you a better ways to manage it. Because had you would have had to manage it, you would have to spend more time and resources over there. Instead, it's AWS who is now actually managing your resources on your behalf. Moving on with respect to the different architecture pillars, Scalability alone is not enough. Imagine an application that scales perfectly, but leaks customer data. It's not secure. Or it scales perfectly, but it's actually costing me a bomb. As I just mentioned, I'm actually horizontally scaling my application, but I don't need that specific instances to be live enough during that specific timestamp. How can I actually build that? Architecture is actually balancing multiple objectives simultaneously. Your architecture has to be reliable, it has to be resilient, secure, and cost aware as well, cost optimized as well. Cost aware is something that each individual should be, and hence your architecture will be cost optimized as well. Every architecture has trade-offs, folks. It can be highly optimized, or it can be very expensive as well. It can be a simple architecture. It can be a flexible architecture. It can actually provide me data in very few milliseconds of time, or it can be reliable as well. So every architecture has some or the other trade-offs. So it is you who have to decide which trade-off is of the utmost importance to you. Is it an eventual consistency, or is it a hard consistency that you require? Is it a build versus buy decision, or is it an operational effort versus the managed service? Every single component that you add into your architecture will be questioned, and there is no right or wrong answer to it. And in fact, if I actually asked you that specific question as well, where what was the problem statement in my previous architecture? There is no right or wrong answer. It can be anything. So every single component does add some or the other trade-offs as well. With that being said, folks, it's an interesting question. Now, consider you have highly restricted resources and you have a massive scale, somewhere around 1 billion. Where would you allocate your budget first to survive the upcoming surge? Consider it's a big billion day, and you need to prep your architecture for the same. What is the right thing that you would do? Would you vertically scale? Would you add more servers, better monitoring? What exactly is that you folks have actually gathered until now from this specific section? What, according to you, is the right answer for this? Tell me, chat. What do you think? Team, I'm seeing some questions from Dreadlit. I'm happy to actually answer that during the end of this discussion. But as per this specific question, what do you think is the right thing to do to handle your Prime Day? The Prime sale is actually going on right now. What do you think, folks? That's good. Database improvement, definitely, because a database can choke down. I definitely need to scale that out and have some read and write replicas itself. What else, folks? That's a good one, folks. Karan, arise better monitoring, 100%. I definitely need to have all my monitors, all my observability set up for me to identify just in case if something goes out or not in a not expected manner. CDN, definitely yes. CDN, I definitely need to optimize my architecture in a way that it actually reaches my or the requests are actually interacting with my static files in a CDN manner, and definitely yes. Karan, you actually hit the bullseye. There is no single particular answer for this. You are absolutely right on this. The goal isn't to find the right answer. The goal is to justify the trade-offs. There isn't any specific right answer for this. In huge or in large organizations, you have a different team who manages the monitoring. There's a different team who manages the complete infrastructure. There's a different team who manages upscaling or downscaling as well. And every single team, trust me, folks, every single team is actually up on their toes and literally looking after what can go wrong and they can actually fix for that part. So every single thing needs to definitely be considered, be it vertically scaled, be it horizontally scaled, monitoring, CDN, database, any specific, everything that can fail will fail. Please remember this phrase or this analogy. Anything that can fail will fail. Moving on to the last part of this architecture, which is the security. As I mentioned, I'll come on to that security part in my architecture later. And coming over here, how can I actually now add security into my architecture itself? The most easiest way is to first authenticate each one of these requests itself, because as of right now, all of these requests are open. Anyone can actually request for anything. The single best thing that I can actually do is add Cognito, and I'll add a API gateway as well. Now, every request will now be routed through an API gateway. This specific, except for this specific request, because this request is directly being handled or directly being uploaded to my S3, which is a secure URL. Every specific request will be going through my API gateway itself. Sorry, API gateway. This API gateway will actually will decide whether these requests enter my system or not by interacting with AWS or Amazon Cognito. Cognito is a service where I personally actually use it for managing all my user tokens, be it your JWT token or be it your OAuth token. This so once this is actually validated and authorized, there's a difference between authentication and authorized. Authentication means that you are allowed to enter the system. Authorization means you are whether allowed to access this resource or not. For example, let's say I logged into a specific session of my own, and I have tons of other records as well. Be it so, I have records of Hardik as well. I have records of maybe some other persons as well, but I can only access my records, and that means authorization. I'm authenticated to enter into the system, but I am not authorized to access someone else's data. Using this, using Cognito, I actually made my system secured. Not fully secured because there are tons of other ways that hackers can actually enter my system. For that, I'll go back to my previous or I'll go back to my slides itself. Security is usually treated as a separate discipline. As you just saw, I actually introduced in the version 5 of my architecture towards the end. That's a havoc. You should have, or I should have, I would rightly agree to that. I should have actually introduced right during my day one itself because I'm actually keeping my users' data at risk. So it should be my day one architecture and it should not be my version 5 of architecture. Every architectural decisions has security amplification implications by that. The easiest way to protect your system is to avoid giving unnecessary access in the first place. Introduce the principle of least privilege one. Consider adding security groups or an IAM or an encryption policy as well. And treat it more like a White House or like a castle or like a parliament itself. No one can actually enter without the proper authorization or the proper authentication as well. The gates are there, the guards are there, there are walls that you cannot cross. Exceptional cases, definitely you can, but not in a technical concept basis. Unit economics, very important, folks. As I just mentioned, I can actually build highly scalable system, but if it is actually costing me a bomb, that's a bad system because if my architecture is highly scalable, but at the same time it is costing the business, and the business is not even is not able to churn the revenue out of that, that is a negative revenue. If my cost of per user is much more than the cost that I actually earn, it is a failed business. It is a failed architecture. Hence, we should always be very mindful about the cost as well. We often think about scalability, we often think about performance, we often think about security as well. Businesses care about performance and sustainability. However, a scalable system that bankrupts the company isn't a successful architecture. And you must have actually heard recent news as well that tokens were actually overshooted and it actually costed, I'm not sure which specific organization was that, but it actually costed the entire year's budget, which was consumed within just a month itself. So if you're not designing for the cost, you are actually putting your foot onto an axis. That is a very bad architecture. So you should always be mindful of the cost as well. Moving on, how we actually evolved right from architecture one, the version one, to the latest architecture. My architecture one just had some single EC2 instances. It had a MySQL database and my local images were there. My database was also locally inside that specific architecture. However, my recent architecture, the most scalable architecture, as per my existing requirement, is this. I decoupled it. I added asynchronous task. I added security parameters. I horizontally scaled it. Sorry, this should not be here, my bad. I horizontally scaled it and added some security parameters as well. And I also added my CloudWatch monitoring as well. So please mind that everything CloudWatch. So everything is being captured by CloudWatch as well. So I need to actually every single instance of this needs to send my logs to my CloudWatch. So I made this architecture, and I'm not saying this is the most scalable architecture. It is not. It will never be. It will keep on evolving. It is based on my existing business requirements that I'm sharing this architecture V5 with you. So my architecture V5 have a in fact, sorry, I didn't actually added a cloud front. Sorry, my bad. I'll actually show you how can I actually add cloud front over here as well. So How CloudFront folks actually works is currently CloudFront is actually empty. How it works is my client will be requesting the static images, be it your images, be it your videos, be it your CSV files or CSS files or any static files. It would first be requesting the CloudFront. If it is not available there, or let me actually put it over here, it would be much simpler. It first checks with the CloudFront. If it is not there, it would then ask my S3, whatever it is. It would then actually ask my S3 to fetch those images which are there on my in my bucket. It would then actually dump it or cache it into its nearest CloudFront location. So the next time when any specific static images are being requested, the network or my client directly fetches it from the CloudFront, and it does not need to take it time and again from S3. Why I actually added CloudFront as well, folks, there is another cost reason as well. Every single request, every single get request from an S3 is a cost for me. Every single get request from a CloudFront is also a cost, but at a very bare marginal value. It almost very negligible. So the moment I actually request this data from the CloudFront, it directly, because it has cached all of those static files, it can directly fetch it from here and can be served back to the client itself. This is the version 5 of my architecture. It has CloudFront, it has a load balancer, I auto scaled it as well, and it has my decoupled managed services too. Please note that I never deleted my application because a version 1 of the architecture was working for a specific set of users, but the version 5 did not. Sorry, sorry, let me actually repeat. The version 1 was actually working for a specific set of users, but the same version was not working for the millions of users. So we evolved our architecture. I never deleted my application. I just evolved it. The systems aren't rewritten every year, they just grow. Please mind that every great system is not rewritten every year. We just grow it. And notice that we never jump from one server directly to the most complex distributed system as well. We evolved one decision at a time. We evolved one requirement at a time. We evolved one stage at a time, wherein at different stages I had different tons of users as well. That's exactly how real architectures grow. The biggest upgrade in my application wasn't my cloud account. It wasn't AWS. It wasn't Python, or it wasn't Django, or it wasn't EC2 as well, or it wasn't RDS or Lambda as well. It was my mindset. That's what architects build first. You need to actually evolve your thinking in order to understand what is the existing bottleneck right now and solve for that. If your There's a great thing. If everything is working, don't touch your system, please. Please don't touch it. It is absolutely working fine. Don't try to over engineer your architecture or your application. Let it work. It is there for a reason. So you don't need to question your microservices, or you don't need to actually question your AWS. You need to actually question your thinking and diagnose the right problem statement, the right bottleneck. That's what great architects like you going to be into the future builds first. Final question for the day, folks. We actually evolved from user 1 to 1 million users. Now, if I have to go to 10 million users, or if I have to grow globally, what should I be doing first? Should I be containerizing my applications? Should I do it a multi-region deployment or use some global databases, event-driven architecture, disaster recovery? What should it be? Question, folks. That is absolutely correct. Multi-region deployment, deep Buddha, definitely 100%. Everything is equally important. Arise, you definitely get something from me. Let's play FIFA offline sometime, if at all you are a FIFA player. But having said that, folks, I intentionally didn't have any specific question with any specific right answer. There is no specific right answer for this. You devise your application, you devise your architecture in a way for on the requirements itself. So it can be containers, it can be a multi-agent deployment, it can be an event-driven architecture, it can be anything. Your business requirements define your architecture. The one of the last slides, we are almost done. The core principles of architecture is please keep it simple. Please measure before you change anything. Please diagnose it. Please actually try to find the right bottleneck. You may need to actually scale horizontally. You need to separate your concerns. If my database is not working, I cannot mix my database and throw that blame onto my application developers. This is most of the time this is usually the pattern itself, that hey, my code is actually working, go talk to that specific person itself. So separate the concerns, separate the modules itself, make your architecture in a modular way, add logs, add observability so that you can actually find the right bottleneck itself. Automate everything repeatable. Very important guideline in today's era, because if you are there manually doing every single stuff, you are designing it for the failure. Design for failure, yes. Most important point, most important point specifically. Every architecture, as I just mentioned previously as well, every architecture will fail. Every specific, consider whatever can fail will fail. Try to add some of the exceptions, how the exceptional scenarios should behave. And the last part, never stop learning, folks. Never stop evolving. Because in today's era, you definitely need to keep upskilling yourself in order to be the best out of the lot. I'll end this session with the phrase that I usually love: architecture or technology always follows a business. Business follows customer, and customers reward simplicity. Everything we discussed today ultimately comes back to serving your users. Technology is only the means. Customer value is the ultimate goal. So don't wait until you're hired, folks. Don't wait until you are graduated as well. Learn by building. Every production engineer once was a student. I was a student as well. And though I wanted to be a cricketer as well, so I saw my future much more exciting towards the technology itself. I wanted to be a computer science engineer as well. So every production engineer like you has was a student who will be deploying their first application. So build, break, learn, and repeat. And that's all from my side, folks. Thank you so much for actually having me. You can actually scan that specific QR code and bombard my LinkedIn chat. for any specific project or concern that you may have for me. I'll be more than happy because I know I was a student, I needed some of the guidance, and I'm all there for the students to actually, or for builders like you, for excited builders like you, to help them and empower them and evolve them to the next stage itself. With that being said, folks, thank you so much. It was a lovely pleasure, and you folks have been a lovely audience. I'm happy to take any specific questions that you folks might have for me. Right. Let me just go through some of the comments as well. And I saw there were some questions being asked, but in the meanwhile, I scanned the chat. You can drop in your questions if you may have any. Can I convert my hard drive at home into an AWS service? Which specific AWS service, Dreadlit, are you talking of? But unfortunately, no, it cannot happen. However, I'll tell you what I specific did during my during my research for the crypto. I actually wanted to offload it for the crypto mining itself. But at the same time, it requires high electricity. It requires high internet bandwidth. It requires high cooling of time as well, and it eventually didn't turn out to be profitable. So if you have easy access or free access, rather, I would rather suggest, if you have free access to electricity, and so because this is one of the examples that I specifically have, but I'm quite sure that you cannot actually convert that into an AWS service. It's just one of the ideation that I can actually share it with you. Your order to just what will happen if I hosted my app through AWS and something happened and the data center where my app was hosted is off or closed or stopped? That's a great question, Dreadlit. If that data center is actually down or for any specific reasons, your app will go offline, and hence it is recommended for an application to be multi-AZ deployed. At the same time, it depends upon situation to situation as well. Not every business deploys it in multi-AZ data centers itself. It is based upon your requirements, and again, you need to actually understand the impact, the impact of your application being deployed into multiple different data centers, because deploying an application of the same size of the same infrastructure in another specific data center is again an additional cost. So you need to definitely weigh in with respect to the cost parameters as well. But to actually answer your question, if that data center is down, your app will go offline, Redlit. I like your question, Redlit. And one by one, how many queries are hitting and loading? Sorry, Pratham, I didn't get your question. You have, and one by one, how many queries are hitting and loading? Sorry, I didn't understand your question. I'm happy to actually answer if you actually rephrase your question, please. I heard about AI usage in companies and that quarterly distribution funds are over in just a span of 2 months. It's a different topic altogether, but I can actually just answer it in a way that every agentic AI system that you tend to build should have some guardrails. And again, as I just mentioned, it's a different off topic. So I can talk about this agentic AI guardrails as well some other time as well. What will happen if my host on through something and okay, so I have already answered this. I have what is a DevRel? I have checked Hardik's profile as well, and you are head of DevRel at AWS. What is it? Sure, right. So, DevRel, we are developer relations. I head the developer relations for AWS at India and South Asia, and we are there for the builders like you to coach you, to guide you, and listen to your specific problem statement in a very unbiased way, and advocate about the AWS services as well. So there's a so consider two scenarios where one is a sales team which works top down, that works with the CXOs. DevRel works bottom up. We work with the builders. We try to actually understand your specific problem statement and provide you the right solution for that. We are actually building the communities like this student builder group as well, where people or builders like you can actually come, participate, learn about things, because alone I can only learn a specific topic. But when I'm actually in a specific community, I can actually learn, interact, network with multiple peoples, empower myself, and learn from the others peoples as well. So DevRel is more of maintaining the relationship with the builders on ground and listening to their problem statement in a very unbiased manner. As I my this complete session, though it actually mentions the kind of AWS services that it can be used, but it was majorly intended to solve a specific problem statement. And hence, that's how we actually work as well. Isn't it the data center is off, then it will be automatic? No, it is not like that, Shrey Patil. It is not like that. You actually need to deploy it into a different data center altogether. How do load balancers improve the performance of the application? So consider load balancer like it is actually balancing out your load to multiple different servers. And so since in my initial V1 architecture, there was just one server and a client that was actually requesting to that server time and again itself. There can be hundreds of clients, but if there is only just one server, all the requests will be bombarded onto that specific server at all the time. But by including a specific load balancer, if let me just go back to my drawing board again. By adding a load balancer, I just actually balanced, or I just actually segregated my request into three different horizontal scaled EC2 instances itself. As of right now, it is three instances, but the more you add, the more the request will be segregated as well. Moving on, I designed MVP using Sentry. That is good. Postdoc, Supabase, Redis, Upstart. Very soon we will be scaling it. And in AWS, can you suggest me how do I manage an app with heavy load on CDN? What do you mean by heavy load on CDN? Because CDN is designed to handle as much amount of load itself. What do I need to learn to become industry ready as a college student? So, Karan, I would strongly suggest you to join the Student Builder Group and our AWS Builder Center platform as well. So over there, you can definitely learn and interact, as I just mentioned, from the different communities, from different students. At the same time, build something irrespective whether it's a small application or if it's a big application, does not matters. I started off by building just a small simple calculator. You can actually do something similar. It's just that you need to understand the concept. The end product does not matters. It can be any simple or basic application. It can be a normal blogging application as well. But just I would strongly suggest build first. break it, and keep experimenting. At the same time, a very important suggestion as well, whatever you are actually learning throughout the way, keep documenting it, keep sharing it with the other folks as well. Because in times like these, I call myself as a builder and a creator as well. Because if I'll give you a real life scenario as well. If I'm actually sharing my knowledge and coming out in public, there are tons of other people who are actually getting to know me in an organic way itself. So it becomes an easy path for me to get into any specific system just because they know me. Now, having said that, I'm not sharing anything that I'm building with the expected outcome. Please do not share with the specific outcome. Just share it because you want to share it. You are just actually sharing your learning. Be a creator, not just be a builder, but be a creator and a builder. Be a creator builder. What are some common mistakes beginners make while building scalable applications? I just actually recited that. We should multi-deploy, like when we have to buy AWS for. So when you actually need to go to a multiple different zones itself, it depends again on your different business applications itself. If your business application is globally itself, I would definitely like to have a multi-AZ deployment itself. And if even a marginal downtime actually impacts your business revenue, you should then also consider deploying it on your multi-AZ system itself. What is the first thing to consider? Do not consider anything. Just build for one user and take it over from there itself. With that being said, folks, I'll hand over the baton to Hardik. Hardik, it's been a great audience, and please take it over to you.
Hello, everyone. Thank you so much for so many questions. And I was looking at the comment. Araz, you said I am managing too many communities. To be honest, I don't even know myself that how am I managing all of those things. Like, I have been into communities for like last 5 years, so it's kind of become habit for me as well. And yeah, I am having issues with the college schedule as well. But as Praful Sir said, he used to sleep very late. I am doing the same thing. So, in order to get something in your life, you have to sacrifice something. And it's one of those things. And if you really love communities, then I would definitely suggest you being part of different communities like AWS student builder groups, like AWS user groups. You can go and attend the sessions there as well. You might be able to learn a lot of things by being part of the community itself. And once again, thank you everyone for joining us. And thank you so much, Praful Sir, for such an insightful and inspiring session. I am sure everyone gained valuable knowledge about designing scalable cloud architecture and understanding the principle behind building reliable and production ready applications on AWS. On behalf of all the organizers, thank you for taking the time to share your experience and expertise with our community. We truly appreciate your support. To everyone who joined us today, thank you for your active participation and for making this session a success. Now, before ending the sessions, it's time for taking the attendance. So let's do that. And meanwhile, I will also share the link as well. Just give me a minute. I have shared the links in the comments as well. And also, guys, we would love to have you all on the AWS Builder Center space. And I know so many of you were asking about the resources. We are working on it, and we will share it with all of you very soon. And once again, thank you so much, everyone, for joining us. I'm seeing the attendance right now. I'm going to wait for a few more minutes and then we will close the live stream. And once again, I'm sharing the form into the comments. ITMBU, you are from Vadodara, right, Bhavik? As per we mentioned about the certificates, we will give it to you after you write one blog on AWS Builder Center and you share in the social medias. It will take some time because we have to check all the things. So please take your time about that. Guys, we are now closing the stream. Once again, thank you everyone for having us. We will see you tomorrow. Have a great day.